As always, the views expressed during today's webinar are those of the speakers, not of Stratford, the speaker's firms, or clients, and are not intended to provide legal or tax advice. We have gathered an authoritative panel to examine how Medicare and Medicaid auditors are using statistical sampling to recover overpayments. The panel will also guide counsel for healthcare providers on how to challenge the sampling results and the alleged overpayment, leveraging lessons from prior matters. Our panel today includes Anna M. Grizzle, member at Bass, Berry & Sims, and she is joined by Dr. Patricia L. Maycoot, president at Research Design Associates. Anna, when you're ready, we'll get started.
Great, thanks so much, and thank you to all of you for joining us this afternoon or morning, depending on where you are, to discuss statistical sampling and extrapolation. And today, what Pat and I hope to accomplish is to provide you with the legal framework for how statistical sampling is used to discuss the substantive establishment of a methodology and some mistakes that can be made, and then wrap up with how to defend cases that are involving statistical sampling and extrapolation. So let's jump into first start for how statistical sampling can be used for overpayment estimation and in the payment of healthcare claims. And our focus today will be on government claims, Medicare, Medicaid audits, but I would note that a number of commercial payers also use statistical sampling and extrapolation as well. And these same concepts that we will discuss can also be used in evaluating and challenging commercial payers as well. In the government context, the frequent use of extrapolation based on the statistical sample will occur in Medicare or Medicaid audits. And in fact, the Medicare program has been using statistical sampling to calculate overpayments going back to the 1970s. Today, we frequently see it used in ZPIC or UPIC audits, OIG audits, as well as in audits by the MAC following TPE reviews, which are a newer review, and the TPE stands for Target, Probe, and Educate. Under this program, a provider is chosen based on data analysis to review 20 to 40 claims for 3 rounds. If there's no improvement after 3 rounds, then extrapolation can be used for an overpayment. In addition to these more reactive uses, providers may also choose to proactively use statistical sampling to calculate overpayments and submitting a disclosure under the OIG self-disclosure protocol to calculate potential damages, as well as part of a voluntary refund to the MAC in the Medicare contractors. The Medicare contractors have developed refund forms, and on those forms it will explicitly state that if a sampling methodology is used, you can explain that methodology, and that can be used as opposed to a claim-by-claim review. And finally, I've noted the potential for statistical sampling and extrapolation to be used in FCA cases. There are a series of cases where the government has attempted to use statistical sampling to establish FCA liability. This is very much an unsettled issue among the courts, with several of the decisions actually in favor of the providers. And so if you are defending an FCA case where sampling is being used, in addition to the discussion we will have today on how to defend against the substance of sampling, I would also encourage you to look at the cases where it has been used in the FCA context, because there will be additional defenses that would be available in addition to the ones we'll discuss today. So to provide a foundation for how sampling is used, we want to give you an overview of what that legal foundation is. And as I noted, the use of statistical sampling for Medicare payments have been in place since the 1970s. And in the mid-'80s, a provider challenged the ability to use sampling in a decision that resulted in the HCFA ruling entitled Ruling Number 86-1 that was issued on February 20th of 1986. This decision is often pointed to as really the first time that Medicare or any Medicare contractor laid out its authority for why it thought that it was appropriate to use it. And this decision walks through CMS's policy on the use of sampling to project overpayments, giving a history and citing the authority, both statutory and precedential, to support its use. And in that ruling, HCFA concluded that sampling does not deprive a provider of its right to challenge the sample, nor of its rights for procedural due process. Instead, it noted that sampling only created a presumption of the validity of the amount of the overpayment, which could be used for recoupment. Once that presumption was established, the burden was then shifted to the provider to take the next step. After walking through this authority, the HCFA ruling then noted that the statistical sampling would not violate due process so long as the extrapolation is made from a representative sample and is statistically significant. Now, from this ruling, the inverse would obviously be true, in that statistical sampling would violate due process if it was not drawn from a representative sample or was not statistically significant. Implicit in this standard, both under the HCFA ruling as well as the Chavez decision, is the standard that a provider must be provided sufficient documentation for an individual review. And the Chavez standard that's noted on this page is the seminal case that addressed statistical sampling for overpayments. And in fact, when you read cases even today, it will often point back to that Chavez decision. As far as documentation to be provided, this has been recognized by Medicare Appeals Council decisions and in district court decisions numerous times. And the regulatory basis, to the extent you're challenged on being able to receive the documentation needed, can be found at 42 CFR Section 424, subsection A, subsection 6, which requires for sufficient information to be furnished to determine whether a payment is actually due. We'll be referring back frequently to the need for this documentation, so we thought it important for you to understand the foundations of it. Following the Chavez decision and other decisions, there was some concern among healthcare providers and suppliers about CMS's ability to use statistical sampling extrapolation in an unlimited fashion. And so in the Medicare Prescription Drug Improvement and Modernization Act of 2003, it included a statutory limitation on extrapolation. Under this statutory requirement, a Medicare contractor may not use extrapolation to determine overpayment amounts unless the Secretary has determined that there is a sustained or high level of payment error or documented educational intervention has failed to correct the payment error. The Medicare Program Integrity Manual in Chapter 8, which we provided as part of our materials, actually provides examples of when statistical sampling can be used under that first prong of sustained or high level of payment error. This can include situations such as high error rate determinations by a Medicare contractor, such as a MAC, a ZPIC, or others, probe samples that would show a high payment error, other data analysis, provider and supplier history, as well as other investigations by other law enforcement entities. And finally, allegations of wrongdoing by current or former employees can serve as a basis for finding a sustained or high level of payment error. The Program Integrity Manual does note that these are examples and that there could be other bases that could be used for this finding. For the prong on educational intervention, it is important when providers are looking at claims denials to consider appealing any adverse claims decisions, not only for the high payment error, but also for the education. In payment decisions from audits, the MAC or other contractor, such as a ZPIC, will provide education in that letter for how payment errors can be corrected. This education can then be used as a basis for extrapolation. Other examples of education include publicly available education that have been provided by the various contractors. And so in light of the ability to use the audit results both to establish a high payment error as well as as for educational intervention, I frequently counsel clients to consider any claim denial of whether it should be appealed. Even if you're looking at that claim solely in a vacuum, it may be considered cost prohibitive. It's important for extrapolation purposes to consider whether it does make sense to go ahead and appeal. And so with these, bringing all of this information together, the historical basis as well as this statute, what we have is that the basic legal foundations for statistical sampling and extrapolation require four main things. One is the determination found on this slide. The second is that the sample must be representative. The third is that this sample must be statistically significant. And the fourth is that there must be documentation provided that is sufficient to replicate the sampling methodology so that the provider has the opportunity to analyze and determine if there are any issues that would provide grounds for challenging it. I mentioned the Program Integrity Manual, Chapter 8, that provides information on statistical sampling, and this is really an important document to review and to be very familiar with if you're defending a client in a statistical sampling matter. And the reason this is important is that you will frequently see references to the Program Integrity Manual, or PIM, and claims decisions and appeals decisions, and you will have it cited by the auditors using extrapolation as well. So I want to spend a few minutes to talk about what the PIM is. CMS provided this expanded guidance on the standards for statistical sampling methodologies in the Program Integrity Manual. But one misconception that I often see in defending clients that will be expressed by reviewers in the Medicare appeals process, including at the reconsideration level by the QUIC, the Qualified Independent Contractor, or by the administrative law judges, is they want to treat the PIM as a checklist so that if a provider can check the boxes for each area that we will describe in detail, then the statistical methodology must be valid and is not subject to be overturned. However, that is not the purpose or the idea behind the PIM. The PIM instead provides basic concepts rather than a checklist. And when applied correctly, the PIM's concepts can lead to a proper methodology because the PIM outlines the basic elements you need to create a sample and to perform an extrapolation. However, when the PIM's concepts are not applied correctly, then you often will not have a statistically valid sample that would be representative of the universe. Sometimes in defending these matters, the response, particularly of experts who may not be quite as familiar with the Medicare process, is the response is to try to dispute the PIM. And that actually is very ineffective because while it's not binding guidance, the various contractors, particularly the ALJ, will give deference to it. Instead, it's important to explain how the PIM can work, and to treat it as a checklist would mean that you would never have a sample that is invalid, because as long as you have a universe, a sampling unit, etc. But instead it's about getting behind the methodology to make sure it was constructed appropriately and used appropriately. And Pat will talk in more detail in a few minutes on how you can get behind the PIM and what you can do with it to be able to show that there are issues with extrapolation and with the methodology. I want to touch on Medicaid statistical sampling and extrapolation for a few minutes as well. Most of our discussion today will be centered around Medicare and the Program Integrity Manual. But again, as I noted at the outset, these same concepts would apply in any sampling methodology when you're reviewing it. For Medicaid, however, it's very important to look to the state law to see what the guidelines are for the use of extrapolation and whether those guidelines were followed. If there is no explicit authority, then you should look to the due process requirements that are afforded under state law in some type of payment dispute. And Another point on Medicaid is that, as we'll talk towards the end on defending, they will have very different appeals processes, and so that is where it very much will deviate from the Medicare process. So it's very important, if you're involved in a Medicaid audit, at the outset to understand when extrapolation can be used and what those appeal rights are, because the time frames can often be much shorter than in the Medicare context. So now let's turn to what must be done to perform statistical sampling. And I'm going to walk through the specific steps that are needed, and then I will turn it over to Pat, who will then delve into each of these to show how it's done correctly and to also give examples of when it's done incorrectly and what the impact should be. The first step is one we've really already touched on, and that is the selection of the provider or supplier for an audit that may involve an extrapolated overpayment. And as we've noted, that could be a number of circumstances, such as a prior history of overpayment error or the TPE reviews conducted by the MACs. After the provider is selected, the next step is the selection of the time period to be reviewed. And this can range from a few months to up to several years. There is a limitation, though, on the time period in that it would be limited to the reopening periods that would apply under Medicare law. And so when one basic step to do at the outset of defending an audit is to determine were they within the right time period that could be audited. After the provider has been selected and the time period for review has been selected, the auditor will then define the universe, the sampling unit, and the sampling frame. The universe would be the claims during the time period that will be reviewed, and that could be all claims of the provider, or it may be a subset of claims. For example, if the concern is about a specific procedure, the universe may be limited to that specific procedure during the time period as opposed to all claims. Another example is frequently physicians are subject to audits for their evaluation and management claims or their office visits. And so in that circumstance, the auditor may limit it just to those professional services and not look at procedures or other codes that may be billed. After the universe is selected, the auditor next must identify the sampling unit, and that is the element that will be selected for review. There are several options that can be used by a Medicare contractor as that sampling unit. That can include a claim, it could include individual claim lines, or it could include a beneficiary as the sampling unit. This is an important area of concern for statisticians because the way the sampling unit is drawn can have a direct impact on whether the sample will be representative of the universe of claims. Additionally, for Medicare, they only paid claims are included within the universe or within a sampling unit that will be selected. This is another area of concern for statisticians because this would not account for any underpayments that may arise for claims that have not been paid. After the universe and sampling unit are then established, the auditor will then draw the sampling frame, and that is simply a list of all of the sampling units that are within the universe. From that framework of the list of the units, they then move to design the sampling plan and selecting the sample. There are a number of methodologies that can be used for a sampling plan, and we'll touch on those in a few minutes, but they include simple random sampling, a stratified sampling, or cluster sampling. After the auditor decides which type of sampling methodology will be used, they then move to selecting the claims that will be reviewed, or the sampling units that will be reviewed. This involves using random numbers, and often RATstats, a program published by the OIG, is used to select those claims. One note here on the use of RATstats to select the random numbers. I have seen auditors note that they've used RATstats for the selection of the random numbers, so therefore the sampling methodology is appropriate because it's using the RATstats formula that has been approved by the OIG. I would encourage, if RATSTATS is referenced, to look to see exactly how RATSTATS was used. If it was used simply to generate the random numbers to select the sampling units to be audited, that does not mean that RATSTATS was used to help to design the sampling methodology, in particular to determine the sample size that needs to be used. Often the auditors will apply an arbitrary number for the sample size based upon resources that are available, and that can cause issues in having a valid sampling methodology, as Pat will explain. After the sample has been selected, those sampling units, whether it's claims line, beneficiaries, where the claims for those beneficiaries, will be reviewed to determine if the claims were appropriately submitted, and if not, the overpayment that would be associated with that sample of claims. The results from the sample will then be taken to estimate an overpayment across the universe of the claims. Now, I touched at the outset on the legal requirements of the documentation that's needed. The documentation that must be documented as well as provided includes each of those steps. In other words, going back to third grade, the auditors need to show their work. You need to be able to see how they went from selecting the provider to the dollar amount and all of the steps in between. And what's important is that when I talk about showing your work, it is again like third grade. It's not enough to show 2 + 2 = 4 and only show 4. You want to show the methodology for how you reached that solution. Sometimes I've seen auditors simply provide a memo that outlines, here's the universe, here's the sampling frame, etc., without actually providing those underlying files. And a memo alone is insufficient. You need to be able to actually see the work files to fully analyze whether that methodology was appropriately drawn and administered. If those files are not provided, it's very important to ask for the information. And I ask always in a letter, and usually have a statistician I'm working with help me to write that letter, so that I am creating a record of my request for information and where there is deficiencies. And we'll talk at the end about why that is important. If you are successful at any level of appeal in overturning individual claims decisions, it's very important to also follow up to obtain, again, the work product showing how that extrapolated overpayment was recalculated. And I will note that this is not information that is proactively provided by the contractor. Often for the initial audits, because of the prevalence of these audits, the contractors are providing, along with the audit results, a CD with that information. But I don't know in all the numbers of audits I've defended that I've ever had that information provided following an appeal unless I've asked for it. The reason this is so important to ask for these calculations is that in my experience I've identified a number of times errors in those calculations where claims were included that should not have been, or claims that were overturned, the provider did not get credit in that recalculation. They will often get a demand letter but not the backup. And so again, it's important to request this information and to, again, have a letter showing that you've made those attempts to get it. So we now want to shift to looking at how you formulate a valid statistical methodology. And we'll start with looking at the specific types of sampling methodologies that can be used. And there are 3 that are commonly used and are referenced in the PIM that you see in Medicare audits. These include a simple random sample, a stratified random sample, and a cluster sample. So what do you mean what am I meaning when I describe each of those? A simple random sample is a list of all the sampling units, and from that sampling unit, they are then, the sample will then be selected for auditing. The PIM describes it well. They describe it as like shuffling a deck of cards and pulling out cards from that deck. This is a frequent sampling methodology used if all of the units are homogeneous. So if you, for example, have a procedure and all the claims will look the same, a simple random methodology could be an appropriate one to use if it's the same CPT code, etc. Another common methodology that's used is stratified random sample, and that occurs where the sampling units are divided into strata, and then claims are selected from each stratum. Those claims are audited, and then the results are brought together at the end. This is a common approach used when you have variations among claims, and you do want to be able to distinguish them, essentially comparing apples to apples as opposed to apples compared to oranges and bananas. And then the final one is a cluster sample, where you have a random sample of clusters as your sampling units. Unlike stratification, however, they will not necessarily have commonalities. And so, for example, if a beneficiary with multiple claims will be designated as a sampling unit, that could be an example of a cluster sampling methodology. This is sometimes selected for, as the PIM notes, more for economics of trying to audit the claims. And the PIM specifically requires that whatever methodology is chosen, it must be properly executed. And what's also important to review is I've seen situations where they will start with one type of methodology and seem to switch midway through. And so you want to be looking for that, because if that happens, it's not appropriate. I will now turn it over to Pat, who's now going to dig into more of the weeds of how the methodology is done.
Thank you, Anna, and good afternoon, everyone. Thank you for joining us today. While statistics may not be the easiest to grasp of the array of skills in your toolkit, my experience is that when providers and attorneys are facile enough with probability statistics, they can make excellent and successful arguments to defend themselves in a CMS audit. You have a list of terms and definitions in your course material. I've not repeated any of these in the slides, so you may want to have that list of terms handy. And in those terms, they're not the most precise statistical definition, but they're rather trying to be a working definition that makes sense both mathematically but also in verbal language. The MPIM, doesn't talk to you about what a valid statistic is. It does talk about statistically valid random sampling. And from it will include a probability sample using the correct formula, following the statistical requirements of the chosen statistic. And in almost everything we see in these audits, it's a point estimate and the confidence intervals. Both are valid statistics if properly executed. There's been some other methodologies, minimum sums and penny sampling, that have not been validated in the statistical literature, so you have a way of going backward against them a bit. But your methodology has to be valid, and your statistic has to be valid in order for them to be used for extrapolation in these cases. I'm going to cover three big topics today. The first is probability distributions, including the normal distribution and its impact on confidence levels. Then a pretty lengthy discussion about the components of a scientifically valid random sample that has to be properly executed. And then to finish with the calculation of overpayments. It's not magic, but you have to have good numbers in order to do it. And numbers are different from statistics. Most of us are pretty good on an intuitive level at adding, subtracting, and doing some simple multiplication. And we can accurately estimate things and have a pretty good feel for a back-of-the-napkin calculation. We sort of know what's in our bank account most of the time, and maybe, if not to the cent, have a pretty good feel for it. Probability statistics are very different than that. They must be calculated according to rigid rules and requirements. And a little bit when statistics come into the legal world, we have competing big thought ideas. As you know, legal thinking is based on laws explained by rules and regulations and guided by precedent using the sharpest deductive logic. Sophisticated verbal thinking about the law and changing information can over time come to produce a different outcome for the same set of facts. The same is not true for mathematical logic. Mathematics is bound by rigid rules with absolute outcomes. 2 plus 2 is 4, not 22. And there's no negotiating about it, no different evidence or different logic. The problem is that mathematical concepts are difficult to describe in words. Thinking in math requires the use of pictures, symbols, which may look like hieroglyphics, and mathematical notation can reduce several complex ideas and operations into just a few lines, but they're often literally in Greek, Latin, or even an invented language. So these symbolic expressions, when they go to words for a semantic description, it's a very difficult process. And often verbal descriptions only approximate the mathematical concept being described. So nuanced and accurate descriptions remain difficult for mathematical ideas. But systematic adherence to the precise mathematical meaning is necessary to follow the proofs and the treatises and the theorems and formula that we use in calculation. No amount of profound legal thinking or argument can alter the mathematical logic. It's so rigid that statistics is only an applied math, if not a real math. So, and we have to understand that the MPIM and the PIM are the same document. We just sometimes use different names for them. The MPIM is based on math logic, and the translation of that math is part of what we're going to try and do today, but is also not evident in much of the writing that goes on about what the contents of the 19 pages of the MPIM are. Statistics, there are a lot of things statistics can't do, and some of them are quite familiar to you. If you're going to ask who's going to win an election. In the last presidential election, it was estimated over combined polls that Mrs. Clinton had a 2 in 3 chance of winning. Well, we held one election. Were the statistics wrong? No, but the interpretation of them had been wrong all along. Your statistics can't tell you the birth date of your child. They can't predict any one event statistically, period. Nor are they very accurate with small samples. And so if you'd say you wanted to know in this subset of 20, at a 90% confidence level, how likely is it that day X will be the birth date, you would be 1 week in front of 1 week behind. And then there are all kinds of errors in that kind of example. Only 40% of people, or only 40% of births happen on the due date. We don't know the distribution, so we can't calculate the confidence levels. We don't know the conception date, and so 240 days after it is statistically not useful. So all of that information that we don't know is the best you can add up to is a week in front of or behind a guess date for a birth. So it's not very satisfactory. Statistics also don't tell you the amount of overpayment in an audit. What it can tell you is how good an estimator, the single sample chosen for that audit, is. No more, no less. And as you've seen, we've just gotten a little bit into the weeds here, and we'll go a little further into the probability statistics weeds. And the reason for this is because we see OMIGs, ZPICs, reviewers, the MAC frequently muddying these concepts. They parrot the words but miss the mathematical content. And so we routinely see misleading and inaccurate ideas reported that they're just statistically wrong. And this process has been successful in recouping large amounts of money without much of a statistical basis. Now, not all audits are bad audits, but it's your job to see that the audit process that you have to defend against has been handled properly. So in a probability statistic, and this comes from the Medicare Program Integrity Manual 8.4.2, you have to know the number of samples of a given size that can be chosen from the frame of the given size. You have to know the likelihood of selection of each sampling unit. You must use proper randomization. You must use the correct formula. You have to accurately measure the overpayments, and you have to properly execute the methodology using the rules of the methodology. Now here, what we have here is how many samples of 5 can be taken out of a frame of 100. And the first example is 1, 2, 3, 4, 5, and then you move over again and you get 2, 3, 4, 5, 6. Or you go down the first column and you get 1, 11, 21, 31, and 41. Go across the diagonal, get a dispersion. There are literally thousands of possible samples of 5 that can be taken in this example. But one thing that cannot happen is you cannot get a sample of 5 when the 100th one isn't there. It's outside the frame. It's a date outside the frame. It's a CPT code not being audited. It's from a different provider. It's in the drug category, not in the equipment category. So the definition of the sampling frame is important, but one of the first things you have to know is how many samples of 5 can be taken from a frame of 100. That's the first of the probability requirements. And the second would be each sampling unit must have a known, and if it's a simple sample, an equal probability of selection. If it's a stratified sample, you take simple samples requiring equal probability of selection within each stratum. And this is probably the most dense slide we'll have today, and to my mind, probably the most important. If you have a single sample, and only one sample is chosen out of a large number of possible samples that could be chosen, the sampling distribution of all possible means provides the mathematical model of what could have occurred, what is possible to occur. And so that's your sampling distribution that you're measuring against. It's your measurement yardstick of statistics. We're pretty good at ounces and pounds and all other kinds of measures, distances and miles and feet. We understand a lot of types of measurement, but very little in our everyday life prepares us to understand using probability distributions as the measurement tool. And then if you have a large number of samples that were drawn from the frame, the mean of each sample could be calculated. Each sample mean would not be exactly the same as the other values. They would differ a little bit from each other, and they would cluster around the central frame's value. In this case, we're talking about means. Different means, the difference between the means and the true sample, because you're taking a sample, the difference between the means and the true mean of the frame comes because you're taking a sample and not measuring the entire distribution, and that's known as sampling error. If you repeatedly randomly sample moving toward infinity from your frame, the means would be expected to fall in the normal distribution, and that last line is the crux of the central limits theorem, which allows all kinds of good things to happen in statistics. So of these possible samples that could be drawn from the frame our green is the frame, and the straight lines are the means. The blues are samples that can be taken from it. And so you can have all of these possible samples and many, many more that would look and be shaped like this. So here you have a skewed sample, and the mean is pretty distant from the mean of the frame. Here you have a peaked sample, and that will give you a very small confidence level because there's not much distribution. However, it's a long way from the mean. This third example is closer to the mean is closer to it, but the shape is different as well. Here we have the one that looks most like the distribution, but its mean is very distant from the mean of the frame. So in this example, you'll find that all samples are not good samples. The sample has to be both of the same shape and with the same statistical components. So what's the big deal about the normal distribution? Well, in probability theory, the normal distribution is a bell-shaped curve. It's continuous, and the mean, median, and mode are the same number. Here we have an example of it. In the middle is the mean. Oops, pointer. Right here we have the mean, and that would also, in a normal distribution, be the median and the mode, the mean being the average, the median being the middlemost number that's a real number, so that's a 50 percentile, and the mode is the most frequent number. So when those three are together, you can fold that distribution in half, and it will be symmetrical on both sides. And because it's a standardized distribution, the first standard deviation accounts for 68% of the information in the frame. The second standard deviation accounts for 95.4%, and the third standard deviation, 99.7%. So you're right out here in the tails of your third standard standard deviation. If you look to the 90% confidence level, we know that 2 standard deviations is 95%, and if you split that in half, it's 2.5%. So your 90% confidence level is going to be just two-sided. It's going to be just inside 2 standard deviations. There are lots and lots of other distributions, and they become important when we talk about the confidence levels. In the normal distribution, we've got your point estimate, which is a type of mean, in the middle. And in a normal distribution, you have the upper confidence level at 90%, just inside of 2 standard deviations, there and there. If, however, you have a distribution that looks like this, where do you put your confidence levels? Now, mathematically, we know where you put them, but we don't know how to draw them on here. And are they really giving you is there a difference? Are they meaningful? Something with low kurtosis, you might be a little bit closer, as long as it's symmetrical, and these two are symmetrical and not skewed. A high kurtosis will give you an amount of peakedness, but none of them is going to give you the same thing that the normal distribution, the bell-shaped curve, does when you're talking about your confidence levels. And since the lower 90% confidence level is the dollar amount that's the overpayment demand amount, this is a big deal. Here is an example. Now, this is not based on actual data, but it is not an uncommon kind of example, where you have a distribution that's skewed, and you have an outlier out here. You have a claim or some claims at $12,072. Your mean is here at 12,000. Your median, the 50% mark, is at 566, almost half. And your mode, the most frequent amount, is 0. And you often find this in cases where there are no overpayment dollars for the most of the things. And so you get a distribution that it's very hard to figure where you're going to put a confidence level there. Again, you can calculate it, but it's not particularly meaningful. So these are real data. This is a distribution from a Medicare audit, and it has the normal curve superimposed upon it. And you can see that the bucket that is supposed to hold all of the data doesn't hold all of the data. There are things above, there are blank spaces between, there's nothing out here on this end, and there's what's probably an outlier over here on this end. So all of the assumptions that the central limits theorem allows you to make based on the normal distribution are in question about the accuracy of the estimation that's made from this frame. If one were to take a random sample from that frame, and it was representative, as this one is, and you just went 1 standard deviation out. You have 1 standard deviation out from the mean. You have the mean here of $430.92 plus the standard deviation, which is $525.51. You get 1 standard deviation above the mean is $956.43, but 1 standard deviation below the mean is negative $94.18. So what you have here is nothing. There's nothing out there. We know we don't have overpayments in this audit. It's just when you fit the normal distribution over the top of these particular data sets, and this is a representative sample taken from the frame I showed you earlier, your statistic is not a good match because your statistic is based on the distribution. And just to take it one step further, if indeed you had you took this and took a confidence level of it, and we'll talk about the calculation here. It's the point estimate, which is the mean of your overpayment amount, plus 1/2 of the confidence interval, and here the confidence interval is 16,778. So 2 of those get you 33, but half of it, when you add half, and I've got my labels backward, I'm sorry, when you add 16,778 to 27,147, you get $10,368, and the upper is $43,000. So when you come over here to this $10,000 estimate, and you see where on the normal distribution it is, it's not there. So where do you put a confidence level on this overpayment estimation? It's unknowable. So some of the things that you need to do, and this is now moving into the second part about this. We talked about a scientifically valid random sample, is you have to properly execute a scientifically valid random sample. That means you have to know the prior error rate, or you have to use a probe. You have to appropriately use data in the audit that can be measured the way you're measuring it. So the data distribution have to match the statistic you've chosen and the methodology you've chosen. Your sample has to be of sufficient size. It has to be created through a replicable random sample. It has to be tested for representativeness, and representative is without bias. We're going to dip back into the weeds for just a minute here. Random comes into play in the measurement error as well. Probability statistics assume that random variables, that all the variables were being used are random, and that there's random variation within the frame. The assumption is then also that overpayments vary across audits, and they vary randomly. And in a particular sample, one audit will vary randomly as well. If the findings differ from random in a particular audit, then that means that the overpayments are in fact actual overpayments in the particular case. So I wanted to make 2 points, one about the probability distribution and two about the expectation of random. Come into play a little bit later in the conversation. What we have in front of you here is the RATSTAT sample size determination screen. And what you are asked to put in is the universe size, the prior history of error rate. So you have to have a number there. You can't say it was a lot or it continued for 2 years. You have to put a number in there. You can then choose what confidence level you want, or you can choose all. And the same thing for precision. So right here up front, you need to be able to have all this information available to you. Now, we sometimes see in audits where someone will say, we had a 70% overpayment rate so we can extrapolate. That's ridiculous. The understanding of when you have to have a rate of, when you have to have all of these numbers here is before you select your sample size, and they're there because you need them to calculate the sample size. So that's the formula for the calculation, but let's go down to the words. Sample size equals the standard deviation of the frame times the frame size squared. And divide that by the 10% precision, which we chose, the frame mean and the frame size divided by 90, that's the confidence level, squared, plus the frame size times the frame standard deviation squared. Now, the reason for going through the formula is, one, to demonstrate that it is a formula, but that it's important that the distribution, the means and the standard deviations, along with your previously chosen confidence level and precision, are all part of what's necessary to get an adequate sample size, if you're going to talk about sample sizes for confidence levels. So you can't say, using this example, that I did a sample of 8 and I have a 99% confidence level. You can't do it. The math doesn't support it. So in this chart we have 80, 90, We have 80, 90, 95, and 99% confidence levels, and precision of 1 through 15. The common one used is a 90% confidence, 10% precision. It's the industry standard. There's lots of talking back and forth about what's not required. But what is required to say a 90% confidence level is that this has to be at least 15. Now, RATSTATS is very good about telling you that when you go with sample sizes less than 30. Sample sizes less than 30 have a whole other realm of statistics that are used for them, and they're different than the statistics that we're using here. So it's necessary to use the right amount of sample. If you're going to talk about a 90% confidence level, you have to have enough claims in there to do it. A sample is a small and yet completely accurate picture of the data in the frame. It's a subset of a statistical universe that accurately reflects the membership of the entire universe in its distribution. It's representative, it's unbiased, and when it is representative and unbiased, then it's a good indicator of what you're looking at in the frame. Representativeness is tested mathematically, and when a sample is not representative, the results are known as sampling error. So here's our frame. You have an iceberg, sky, clouds, sailboat, and water. Here's our sample over here. Accurate reflection, accurate picture of the frame. But if we wanted to know about the sailboat, we wanted to be sure the sailboat was really what we were interested in, we'd have to have a very, very big sample, because you can see in a small number you're not going to get very many sailboat claims. If we wanted to know in equal proportion, we would then probably go to a stratified sample where you would be taking a specific number from the iceberg so that it's representative in the sample, and a specific number from the ocean because it's represented, and you'd have a specific number from the boat, and it would be then multiplied back over itself. So what do we know? We know that if you don't have a good sample, you don't have a very good chance of knowing where that where that confidence level should be. We know that at a 90% confidence level, you anticipate that 10% of your samples will be bad ones, that they don't fit the distribution, they're not close enough, they're inaccurate. If you have a bad sample, you just are inaccurate. All right, we're going to now move into the extrapolation. We're going to start with the formula. Valid outcomes require the proper execution of the formula. And the formula expects this whenever you put the numbers in. It expects that you have met the requirements of a scientifically valid random sample, that the universe is properly defined, that you have established a prior error rate, that you have properly defined the sampling unit in a way that your methodology and statistics can measure, that the sampling frame contains everything that belongs and nothing outside, that you have defined a precision and a confidence level that you want, that there is a knowable number of samples of the size of your sample that can be obtained from a frame of frame size, that each sampling unit has an equal probability of selection and therefore are independent, that you produce a probability sample of an appropriate size, that the randomization can be replicated and is proper in its use, and that you meet the assumptions of the probability statistic and the sampling unit, and meet the assumptions of the statistic, and for the point estimate and confidence levels, the assumptions are that they will be random, independent observations, normally distributed, and representative. You have to use the correct formula, and if you don't meet all of those criteria, this may not be your correct formula. And you'll see the confidence, you'll see that the formula for the point estimate is pretty straightforward. It's the average overpayment, it's the sample average times the frame size. It's not too tough, you can follow that. And your confidence level is equally straightforward in a formulaic way. It's the point estimate plus or minus the alpha comes from what you've chosen as your confidence level. The confidence level divided by 2 as a two-sided confidence level, multiplied times the sample standard deviation, and then you multiply that times the square root of the following. The frame size times the frame size minus the sample size divided by the sample size, and take the square root of that. Now, it's mathematical, yes, but it's a pretty straightforward idea. What you're saying is the proportion of your sample and its distribution relative to the frame and its distribution. And you do some math magics with it, which work fairly well as long as you've met all of those criteria we just reviewed. And now, a question that I often hear: what does precision mean and what does accuracy mean? Well, precision measures how often the same tool produces the same result each time it's used. Accuracy measures how close the sample value comes to the true value of the frame. So how close is the sample overpayment mean to the true mean of the overpayment frame? Sample results can be accurate and imprecise. They can be precise and inaccurate. You need both of them in order to have a meaningful extrapolation. Calculation of a point estimate, again, for precision, you have the point estimate and plus minus the precision amount, and that equals your confidence level. So it's the point estimate times the calculated precision amount. You take the precision amount, you divide it by the point estimate, and you get your precision percent. And I often hear that it's taking the lower confidence level of the frame gives you something that's in the provider's benefit. It's utter nonsense. You're only as accurate as an estimate as the top and bottom boundaries of the confidence levels around the point estimate. You can be no more accurate than the precision level. And let's take an example of 5 in our frame of 100. And the frame ranges 100 with a range from 500 to 5,570, and the frame has a mean of 2,827. Now let's say you take a random sample, and it turns out that your random sample is the top 5 claims of the frame, and it's possible to get that randomly. So your claims are 5,540, 5,550, 5,555, 5,560, and 5,570. And the mean is 5,555. That's your mean of your sample, randomly selected, and that's the mean of your frame. The precision around that, because there's very little variability, will be very small, and your confidence levels will be very tight. But your point estimate is nearly twice as large as your frame mean. Precision would be good, but the accuracy is not. The point estimate in cases like this would exceed the actual amount paid. It's a bad estimate, and we see that. So talking about accuracy, let's say that that's the mean right there in the middle that we want. And our sample of 5 is right there, those 5. But they're very dispersed. The precision is not very good. And then you've got this sample of 5 over here. It's a little tighter, and the precision is a little closer. But its accuracy, its distance from the mean is quite far. And there you have a very, very tight group of 5 claims, your top 5 highest paid claims, and they're very far, so it's precise and inaccurate. Take another sample of 5 from that same frame. You have a random sample of 5 selected that selects the 2 top claims and the 3 bottom claims. So you have 500, 525, 540, 5,000, 560, and 5,570. You get a mean of 2,539, which is a lot closer to your frame mean of 2,827. The precision will be very large. Precision percent will be very large. The confidence levels will be very large, but the point estimate is close to the frame. So the precision is unacceptable, but the accuracy would be okay. The low confidence level in this case could easily be a negative number, and we know we didn't have any underpayments. So it doesn't fit. It's a bad estimate. The things that you need for the mathematical, the things that you need in order to get good results, or you need to meet the mathematical requirements of the methodology. You need to meet the mathematical requirements of the statistic. You need to meet the requirements of a probability sample, and that's the first one that's measured, that's mentioned, even mentioned in the MPAM. You have to accurately measure your overpayments, and you saw how accurate and inaccurate it can easily be. You can't use a bad sample, and bad estimates are unacceptable. So how bad could things get? Well, if you don't know the prior error rate, your sample size is too small to support a 90% confidence level. You have problems with randomization, independence, and tests for randomness not being done. You have problems with improper implementation of the sampling process itself. You get things that don't belong. You fail to meet the criteria of the chosen statistics, and that in point estimates and confidence levels is independence, random sampling, normally distributed, and representative. Or you ignore the non-sampling errors, which can be even more impactful. And that all leads to inaccurate measurement. And that gets you nowhere. You've done all of this elaborate maneuvering, and as you saw, some of it's just trying to make sure that the distribution matches the distribution of the sample and the distribution of the overpayments match the distribution of the frame. If the sample doesn't, and you don't have it, and you cannot, if it's as unnormally distributed as the examples I've given, then you have to test to see if the central limits theorem will even apply. And if you find out that it doesn't, the simulations say that it still remains significantly not normal, then you can't use these statistics, and you may not support the idea that you can do all of these things wrong and say, we are 90% confident or 95% confident that we're accurate. It's just nonsense. So back to you, Anna, from the deep of the weeds.
Great. Thank you, Pat. So now we want to bring all this together. How do we defend against the use of statistical sampling and extrapolation in audits? And in the Medicare context, you follow the Medicare appeals process. That is the 5-step process outlined on the slide. For Medicaid appeals, the appeal rights would be triggered under state law, or potentially if it's an MCO, if you have managed Medicaid, it would be in your provider agreement or the provider manual. For each of these, the timelines vary, and in particular in the Medicare context, if there is concern about recoupment, which there often is if there's an extrapolated overpayment, the time frames to stop recoupment are shorter than for the appeal. And so I want to walk through those time frames. For redetermination, you have 120 days from the date of the demand letter to submit the appeal. And this is different from the other levels where it's triggered off the demand letter and not the audit result. However, if you want to avoid recoupment, that appeal needs to be in within 30 days. For reconsideration, you have 180 days from the date of the redetermination decision, but to stop recoupment, you have to submit that appeal within 60 days of the date of the demand letter. At the final 3 levels, ALJ, Medicare Appeals Council, and the Federal District Court, you must submit each appeal within 60 days of the prior decision. However, after the reconsideration decision is issued, you typically cannot stop recoupment. Now, that being said, the Fifth Circuit recently issued a decision that did enjoin the recoupment after reconsideration, where a provider had a multi-million-dollar appeal, and because of the significant backlog at the ALJ, would have been put out of business if the recoupment had occurred. And so this is actually the first decision that does recognize the right to stop recoupment in those circumstances. So that is one very helpful for providers. If you're in that situation, I would encourage you to look at that case. For Medicaid, the appeal rights are under state law, and I would note that they vary significantly from Medicare and often with shorter time frames, so you want to make sure you know what those are. So how do you defend against the extrapolation results from a more substantive perspective? I would note that for the decision that we noted on slide 9, the decision of when to use extrapolation is not appealable once that determination is made that it's appropriate to use sampling and extrapolation. However, the determination must actually be made, and that means that there should be some finding in the record that's available to the reviewers to show that the contractor had made that determination. The reviewer will look at the entire record, not just necessarily for what you often see a boilerplate statement of, we find it's appropriate to use sampling because of the high error rate. But I have been able to win on appeal where there was no finding in the record, so it is important to look for that. Additionally, it's not sufficient to say that portions of the Medicare Benefit Integrity Manual were not followed, or that there can be a better or more precise method. I know in discussions I've had with CMS on this, I sometimes will get, well, what we do is good enough. It doesn't necessarily have to be perfect, especially from a statistical perspective. It often can feel like an academic discussion. And so you have to frame it, not that there are better methods, which in working with a statistician, it's helpful to educate them on that importance, because from a statistician's perspective, saying there are better ways to do it is their way of saying this is invalid. So it's very important as lawyers to help them frame it in the right language. You can challenge the validity of the sampling methodology based on the actual statistical validity of the sample as drawn and conducted. So the test is the sample statistically valid? Now, I would note where the contractor does have the burden of establishing the sample was, in fact, random and statistically valid. But it's important to note that if they can produce the data, there is a rebuttable presumption that it was random and statistically valid. So it's then up to the provider to rebut that presumption and demonstrate why it is not appropriate. So we want to talk about some procedural and substantive challenges, and we've mentioned throughout the importance of the documentation, and this is where having all of the documentation is so important, or to be able to demonstrate that you've asked for it and they didn't provide it. There are a number of cases that address the fact that the contractor is supposed to provide the work paper so that, again, you can be able to show your work and see what's needed. And, in fact, in one decision that we've provided in the materials, it is the Podiatric Medical Associates Medicare Appeals Council decision that was issued on January 22nd of 2010. The MAC upheld an ALJ decision to not allow the extrapolation to proceed, and the description of this is very important, and again, it's why you should be asking for it. The Appeals Council noted that it's well established that due process affords an appellant provider the right to examine audit results in order to mount a proper challenge in the appeals process. It then goes on to note the inaccessibility of the information that was forwarded demonstrated that the record was incomplete and that the appellant had been deprived of its ability to review the extrapolation in question. This is why, if you remember when we were talking about the documentation, I noted that you want to have letters asking for that information so that you are building a record to show that if the information was not provided, you made attempts to get it, and by not providing it, your client has now been deprived of due process. A second procedural ground is to review, did the contractor follow the guidelines? Now, as I noted, failing to follow the guidelines alone is insufficient to overturn an extrapolation. However, you want to examine at the outset, were the guidelines followed? Because often if they were not followed, it's going to lead to substantive issues that will provide grounds for overturning the extrapolation. Then the next 2 points on this slide I would describe more as the math. And that is, you want to examine at every stage the supporting documentation so that you can see, were there claims that were included in the overpayment sample calculations that should not have been, and were those calculations performed correctly in the audit and at each level. This is crucial because often when you're examining, where you're digging into those spreadsheets and comparing, you can find mathematical errors, and those should be corrected. In addition to correcting those and continuing to raise those on appeal, I often will reach out to the Medicare contractor to try to work out any of those calculation errors if possible at that stage, because again, with the backlog right now at the ALJ, if these errors continue and you're only addressing in the appeals, you may be subject to a significant recoupment, and I found that sometimes the MAC will be willing to look at that and to make sure the calculations are done correctly. Short of that, however, you do want to raise it in the appeal. For the substantive issues, I will note that in defending provider clients, it often feels that you're fighting an uphill battle, particularly when you look at the Medicare Appeals Council decisions that are available. because the threshold that they're often starting with is that there is no generally accepted statistical standard. And that has actually been cited in MAC opinions, and we've provided one of those just for your reference. And so your job is to explain that there are some basic standards in statistics that are accepted. Those must be followed, and that this isn't an academic discussion. This is where you need a statistician to make that case. And places to look for one can include local colleges and universities. Consulting firms often have statisticians available, and to ask other attorneys for suggestions to see who they've worked with and who they may like. The key to challenging the decision to use extrapolation is to take a very complex academic situation and break it down so that it is simple for the ALJ to understand. And that's where it's very important to remember the audience. And I will often tell the statisticians I work with, I chose my college major in part because I only had to take 2 maths. And so if I can't understand it, we have to assume that the adjudicator, particularly an ALJ, isn't understanding it either, because those are lawyers and may be just like me, where they chose their college major so they didn't have to get involved in math. And so you want to break it down to explain what the issues that have been identified and how those issues do not meet the legal standards they are required to make. And that involves asking a number of questions in the areas that Pat has addressed. I would note that if you look at the MAC decisions, and they are available online dealing with extrapolation under a tab called Overpayment Claims, you will see that a number of issues have been addressed in the substantive issues that we've discussed, and in many of those decisions are unfavorable. And so it is important to review those decisions to see what has worked, what has not worked, and to take that information and have your statistician review it so that you can craft arguments to explain why you should succeed. As we noted earlier in a discussion of the Program Integrity Manual, that is often used as the standard of, as long as you can show me you have a universe file, as long as you show me random numbers, as long as you show me the sample unit, that's sufficient. And so it's important to anticipate what those arguments will be and to proactively consider how do we address those to be able to demonstrate to the reviewer that that isn't necessarily the correct way to look at it, because if all you're doing is checking, yes, we have those things, if you have a bad formula and you feed numbers into it, you may still get the same number, but that doesn't mean the formula was not incorrect. And so we've outlined on these 2 slides of just the questions and the areas that can come up from a substantive point of view. Pat, do you have anything to add on either of these slides?
No, Anna, I think that you're covering them just well, and actually I'm kind of taking notes on my end how to be a better expert.
Yeah. And you can see as we outline these substantive issues that Pat has discussed of sample size, of precision numbers, and just the various questions that can come up, such as probability samples, etc. These are highly technical and very much require trying to get into the weeds. And so it's similar to any case where you have experts. You want to present it in a way that it's very simple for people to understand. Some other tips to consider are, we've already discussed in detail the importance of obtaining the documentation. And it's also, we've talked about the timelines. It's important to raise a sampling challenge at every opportunity, because what you want to do is to avoid any argument that you've waived it because it has not been waived. So how do you do that, especially in the context of the Medicare appeal system that are dictated by forms and appear to be very formulaic? I raise it in a cover letter with for redetermination or reconsideration, as well as in the ALJ, and we'll talk about the ALJ in a second. In this cover letter, I present my arguments and include the expert report so that there's no question it has been addressed. The forms don't necessarily yield to that, and so that's why I like to go with a cover letter approach. Now, on redetermination, you can have a challenge because they can begin recoupment at 30 days after the demand letter, and that is often difficult to be able to respond with an expert report. And so if I need to avoid recoupment with a client, we go ahead and submit our request. We note that we're challenging it, and we note that we think there are issues, but note that in the interest of time, because of recoupment, we're having to get it in and reserve the right to supplement. If a decision is issued prior to be able to get that expert report in, you then can still submit it reconsideration, but you've preserved it. You've triggered their obligation to do an independent review, and I have been successful, even in cases where we've not been able to get in that report, having it overturned because of the significant flaws. Now, I would note for the ALJ, something that's a little bit of a change over the past year or so is there were some changes in regulations that when you're requesting an ALJ that involves sampling and you're wanting to appeal that, it's important to assert the reasons for your disagreement with how the sample and or extrapolation was conducted. Now, CMS has really not given much guidance on what that means to assert the reasons. And so in discussions that I've had with ALJ hearing clerks, we include an outline of those reasons, and we also go ahead and submit our expert report from reconsideration and then reserve the right to submit a supplemental report at the ALJ to address any new issues that have been raised. And the ALJ hearing clerks have informed us that they think that's sufficient to preserve those issues and make sure that they're there. And then final points are you want to understand the reasons for denial at each level, make sure you're addressing them, and prepare written statements, your written expert reports, and your ALJ testimony, again, in very easy to read, understandable information. Because this concept is so complicated, I find that experts often, just like Pat has done here, will use diagrams or illustrations to be able to make their point, and that can be effective. One point on the oral testimony of the ALJ, contractors are more frequently appearing at the hearings, but unless they are entering an appearance as a party, they are only a participant, and so you have no right to cross-examine. One way to address that is to proactively prepare with your expert what the points would be you want to point out in cross-examination, and the ALJs typically are deferential and will give latitude to allowing a response to statements. And so that is a way to make the points about the concern without with having the limitations of not being able to have cross-examination. And so with that, I know it is now time for questions. We will turn it back over to the moderator.
All right. Thank you so much, and thank you both for your insights today. I do need to make a brief announcement because New York State does require that you record and report the following code in order to obtain CLE credits, either for the live or the recorded version of this CLE webinar. If you will be requesting CLE credits for this seminar, please write this code down. The code is TLEHCL. So that's T like Tango, L like Lima, E is in Echo, H like Hotel, C like Charlie, L like Lima. So again, TLEHCL. And now on to our live question and answer session. Listeners, you may ask our speakers any questions relevant to today's topic. You may email your questions to healthlaw@stratfordpub.com. You also can submit your questions by typing into the Q&A box at the bottom left corner of your screen and click Send. Also, you may ask by telephone. To do so, press *1 on your touch-tone phone. Again, *1. But if for any reason you decide not to ask your question, you can press *1 again to exit the question queue. After you press *1, when it is your turn, I will announce the first name and city for the person registered to your location. If you'd like to identify yourself further, please do so. Please remember that if you are asking your question by phone, to turn off the sound on your desktop. First question is, can you explain what probe sample is?
I'll do that. This is Pat. A probe sample is an exploratory sample. So you've narrowed down the time frame you're going to look at. You have decided what providers or codes or combination you're going to look at, but you don't know what your error rate is. You just don't have a feel for it. And it's quite common when there's some voluntary repayment. You know that you have some problem, but you don't know what your problem is. So you take a sample, and it can be random or systematic. Sometimes when you get to your frame, you'll see some claims that are just outrageously big. You can't figure out what they are. So you look at 5 or 6 of them and see if there's a systemic mistake in there that you can understand. And then often you'll take a random sample or even a systematic sample. Let's say you have a 15-month time frame you're looking at, and you would take somebody the 5th day of 15 months, so a claim from that. It's a way to understand your data, and it really is helpful in further defining your frame, and of course it's necessary to know what your error rate is to start your sample size and the rest of your effort. But it sometimes tells you that you really just need to redefine your question. It's not unusual for someone to come and say, we've got a problem in an emergency room, and we'll look at it and we'll do a probe there, and we find out the problem's not in the emergency room, it's what happens after the emergency room that's the problem. Or it just tells you and it doesn't have to, it can be systematic or random, it just tells you what you're looking at so that you don't go and you have your error rate, but also so that you don't go and pick a sample of 100 and you find out you only needed 50 of them because you didn't design it well. You didn't understand the error rate you were looking at.
Okay, next question. Can private insurers use statistical sampling in overpayment demands? If so, do the same rules that apply for CMS audits apply? Also, if insurers can use statistical sampling, what is the legal authority that states so?
And I'm happy to take that question. Private insurers can and often will use statistical sampling in calculating overpayment demands. They do not have to follow the regulations that we've discussed today from Medicare or what would be in your states for Medicaid purposes. But the concepts we discussed from more of a substantive of how to draw a sample and potential challenges would all still apply here in the context of attacking the validity of what's been performed. As far as the legal authority, the first place I would look for what authority they have and what limits they may have would be any provider agreements or the provider manuals, particularly those that discuss the audit rights. For commercial payers, as far as a time period for audit, that time period is going to be much shorter than what you have in the Medicare or Medicaid context, where for Medicare purposes, for example, there is a 6-year look back for potential reviews under the various standards, as well as for voluntary refunds. In the state context, it's typically dictated not only by contract, but your state insurance statutes will also set forth the limitations for when they're allowed to attempt to come back in. As far as legal authority to allow them to use sampling methodology, I would really be looking at your state insurance laws, and I think rather than allowing, it's going to be looking for any arguments you can make that would limit the ability of what to do, because it's going to be more in the context of a negative as opposed to explicit statements, since again this is going to be in the commercial context, and so it will be insurance laws to ensure fair dealings with your private payers. That would especially apply for out-of-network situations where you're not necessarily going to have, obviously, your contract in place. But the contract is where I would be looking first to look at what those standards may be and what may come into place. Pat, have you done any audits, defensive any on the commercial side? I was interested in your perspective from the statistical point of view.
Yes, I have. We've done on both doing them and reviewing them, and it's kind of interesting because for whatever series of reasons, everyone's gotten just as sloppy about their statistics as using the kind of Medicare example, and it's we don't have to be any more accurate than they are. So the real push and the real struggle that I have when working on those or reviewing them is to say, no, you got to meet the statistical standards. And I don't ever see much, if the statistical standards are met, then there's not much pushback at all.
Okay. One other tip in the commercial context as well to consider is looking at the time frames for appealing various claims. I know I mentioned that on the Medicaid side that it can be significantly shorter than on the Medicare side, and that is even more true in the commercial side. And what I sometimes also find with clients is that they may not even have the provider manual that will outline what those appeal rights are, and sometimes the payers make it challenging to obtain it. And so when you're retained by a client on a commercial audit, I would quickly get your hands on what those standards are to make sure you haven't waived appeals, because sometimes that time frame, again, can be very short. That is also something for your clients that you frequently work with, is to alert them to the fact on the commercial side, we're seeing a significant uptick in audits on the commercial side, and I would encourage them that if they get a bad audit and if they are anticipating they may want to appeal, to figure out what those appeal rights are quickly. I know sometimes it's clients working through internally to decide first do they want to appeal and second do they want to get outside counsel. That can take time to work through, and I've had situations where when we get the audit results, we are often sometimes too late because the time has passed for appeal. So again, time frames are very important so that you haven't unnecessarily waived whatever rights you may have there.
On that topic, because the statistical piece usually comes after that, it is not unusual for it to be too late. So if once they decide to take an outside attorney and to do a statistical thing kind of within hours, you need to get the data.
Yes, that's again, and again, same rules and same recommendations of creating a record of asking for the information in writing and keeping a record of that so that you have a good record if you do have to challenge it either through arbitration or in court, depending on what the process would be for the commercial payers.
Anna, do you have you seen much the push? One of the pushbacks against sample size is that the MPIM says that the argument of sample size alone is not sufficient for an appeal. And how do you find the comeback to that? I mean, from a statistical standpoint, it's if it's not large enough to support, if the sample size is not large enough to support the confidence level that you assert, then it's all bogus. But I'm sure there has to be more comeback to that because you see it very often. You can't say the sample size isn't any good.
Yeah, and again, I think that's where you want to continue to try to couch those arguments and why, if the sample size is too small, why that makes it statistically invalid and unrepresentative of the universe. And I will, working with experts, always want to tie back those opinions, because that is a frequent critique of, well, sample size doesn't matter, but sometimes the reasons when you dig into, well, why did you pick the sample size, it's very arbitrary. I mean, I've had situations where reviewers will say, well, that's what the budget allows. This is to audit this number of claims, and and fortunately, for them, the statistical standards aren't, well, what can we pay for? It's what can be a valid sample size to come into play. And so tying it back to those legal standards is what I frequently try to do. And I would note that where I mentioned that a number of the Medicare Appeals Council decisions have been unfavorable. We did include in our information one that was favorable because I think it's important to read those and to see not only arguments that have been rejected, but what's been allowed as well.
Alrighty, thank you. Thank you, everyone. We hope that you have enjoyed our national webinar, Medicare and Medicaid audits using statistical sampling and extrapolation, challenging methods and results. If your question was not answered, you may email it directly to our presenters. Their email addresses are included in the presentation materials. If you are seeking continuing education credit, you must verify your participation in this webinar. You'll do that by completing and submitting the attendance affirmation evaluation after the program. A link to this form will be included in the thank you email that you will receive immediately following the program. As long as you have registered and paid for this program by 5 p.m. today, you will receive your certificate of attendance within 24 hours. If you have any questions about continuing education credit for this webinar, please call our Continuing Education Department. That number is 404-881-1141, extension 2. Today's participants can order a recorded version of this event. You'll get a special attendee price. Please call our customer service at 800-926-7926, extension 1, or visit Stratford's website at stratfordpub.com. If you are not yet a Stratford Annual Pass holder, try the CLE Individual Annual Pass. You can get all of your CLE credits for one low price. Simply respond to the email that you will receive after the program. Stratford would like to thank you for your attendance. To end this call, simply hang up your phone. Thank you and have a nice day.